Here we have A times A times A times A times A. So A is being multiplied by itself, if you want to say 5 times, right? Because I'm seeing 5 copies of A. 1, 2, 3, 4, 5. So I can simply write this as A to the 5th power. Easy cheese. This is what we call the base. It's the thing that's being multiplied by itself repeatedly. And this is what we call the power or the exponent or the index. It tells us how many times we're multiplying the base number. So for instance, if we had b raised to the 3rd power, b would have been our base, 3 would have been our index. And this is just telling us that we have b being multiplied by itself 3 times, or we have 3 copies of b being multiplied. So I'm going to have b times b times b. Let's play around our indexes a little bit more. So let's say that we have a to the 3rd power, which really means we have a being multiplied by itself 3 times, a times a times a, and we were multiplying that by a to another 4th power, which means I'm multiplying a 4 times again, a times a times a times one more set of a. So when I look, this is the expanded form of a to the 3rd. So I'm multiplying a by itself 3 times, 1, 2, 3. And this is the expanded form of a to the 4th, 1, 2, 3, 4. How many a's would I have had together? 1, 2, 3, 4, 5, 6, 7. So I'm going to get a to the 7. So a to the 3rd times a to the 4th is equal to a to the 3 plus 4, which is a to the 7. Easy cheese, don't it? Let's look at this example. We have a to the 2nd power multiplied by a to the 9th power is equal to a to the x power, right? So based on our laws of indices, we know that once the bases are the same, I keep the base and I add the powers. So I'm going to add 2 plus 9. So that should give me a to the x. Now because the bases are the same, I can just equate the powers, which means to set the powers equal to each other. The one on the left hand side should be equal to the one on the right hand side. So what are the powers that we have on the left hand side? If you say a, or if you say 2 plus 9, that is exactly it, 2 plus 9. And what is the power that we have on the right hand side? It's just x. So 2 plus 9 should give us the value of x. 2 plus 9 we know is 9, 10, 11. So the value of x is 11. So I can rewrite this as a to the 2 times a to the 9 is equal to a to the 11. See that? Simple cheese. Suppose now I had this example. A to the y times a to the 4th is equal to a to the 12th. Ask yourself, what are we doing? Multiply. Are the bases the same? A and A and A? Yes, they are. So once we're multiplying and the bases are the same, what should we do to the powers? We should add them. Very good. So I'm going to write back the base and add the powers on this side. So I'm going to have y plus 4 should be equal to, keep at my base and my index up top, right? So because the bases are the same, I can equate the two powers on the left hand side and on the right hand side. What are the powers on the left hand side? Y plus 4. And that must be equal to the power on the right hand side, which is 12. Now, I have to solve this equation for the value of y. What number plus 4 will give me 12? Let's say that I don't know. I can simply rewrite it. So what I need to do is to carry this plus 4 over the equal sign. Once I carry it over, the sign will change from plus to minus. So the value of y will be equal to 12 take away 4. So y is going to be equal to 8. Let's see if it actually makes sense. So we had a to the y times a to the 4 is equal to a to the 12. We said that we worked out y to be 8. So I'm replacing this y with 8. Because the powers are the same, the bases are the same, I'm going to keep the base and just add the powers. Right? So 8 plus 4 is 12. Right? And 8 to the 12, they're both equal, so I know that that is correct. Let's look at this one now. We have a to the 5th, and this time we're dividing by a to the 3rd. Now, I can rewrite this as a fraction, right? As a to the 5th over a to the 3rd, right? This division here sign really means dividing, or it's really turning something into a fraction. I can expand this. Remember now that this is the base that we're using and the bases are the same. And the exponent tells us how many times you have that base being multiplied by itself. So this is telling me that I have a multiplied by itself 5 times. So in the numerator, I will get a times a times a times a times a. 1, 2, 3, 4, 5. And in the denominator, I will have a times a times a. 3 a's, don't it? So 1a can cancel with 1a down here. So see there? Another one in the numerator, cancel another one in the denominator. Can I cancel any more? Yeah, man, one more. So what am I left with? 2a's at the top, don't it? So this will end up giving me a to the second power. Look at what happens. If I have a to the fifth divided by a to the third, bases are the same. I can keep the bases and just subtract the powers. So 5 take away 3 will give us how much? A to the 2, or a squared. Isn't this way easier than this? So once we learn how to use the powers of the laws of indices, we can actually simplify and work faster. Let's look at this one. Here we have a to the 6th power being divided by a to the 4th power is equal to a to the y power. Remember, we have the same basis, a, but this time we're dividing. So once we're dividing, we're going to write back the same basis, but this time we're going to subtract the powers. We keep in the order. The first power come first, second power come second, right? Bases are the same now, don't it? Over here and here so. They've always been the same. So what we need to do now is to equate the powers. So I'm going to have 6 minus 4 is equal to y. And 6 take away 4 will give us 2. So y is equal to 2. Let's look at this other example. Very interesting. What do you notice? The bases are the same. Very good. And the powers are also the same. And we're dividing. Now, I could rewrite this division problem as a fraction. So I'll get a to the third over a to the third. Now, I can expand this and get a times a times a 3 times at the numerator and a times a times a 3 times in the denominator. So a into a goes 1 and a into a goes 1. A into a goes 1 and a into a goes 1. A into a goes 1 and a into a goes 1. 1 over 1 is the same as 1, right? But interestingly, when we're dividing and the bases are the same, we keep the base and subtract the powers. 3 take away 3. So 3 take away 3 is equal to 0. So I'm going to have a to the 0. So any power or any base raised to the 0 power is equal to 1. Exactly equal to 1. It no matter what the base want to be. As long as the power is 0, it's going to equate to 1, as we can see here. As long as the base is 0, the index is 0, or the power is 0, your answer is going to be 1 when you evaluate it. Here we have another example. Now remember, the number at the top, the little number at the top is the index, which tells us how many times something is being multiplied or how many times something is being copied. So this 2 is telling me that whatever is inside of the bracket, no matter what it wants to be, if it wants to be money or if it want to be a fun, anything with the inside of bracket, that is what is being multiplied by itself this amount of times. So a to the third to the second power is the same thing as a to the third times a to the third. How many times do I have a to the third? 2 times. That is what this 2 indicates to us. So now, if I'm going to expand this out, a to the third is a being multiplied by itself 3 times. So I'm going to have a times a times a. And this part is what that represents. And I'm multiplying another a 3 times. A times a times a. How many a's are we multiplying together now? Count them up with me. 1, 2, 3, 4, 5, 6. So I have a to the 6. Now check it out. If I should multiply these two numbers, what would I end up getting? 3 times 2 is 6. So that's a shortcut in doing it. So we can say a to the third squared is equal to a times 3, or a to the third times 2, like so, right? And bases are the same, we keep at the base, and 3 times 2 will give us that 6. Let's look at this example. It seems hard and difficult, and oh gosh, why sir have to give you this? But when you think about it, it's very easy. Now remember, once we have a power being raised to another power, we simply multiply the powers. We keep the base and multiply the powers. So ax to the 5 is simply a to the x times 5. And that should be equal to a to the 30. Right? Now that the bases are the same a, what we need to do now is to equate the powers. So we're going to have x times 5 must be equal to 30. I think you might see something like this before. So I now need to think about what number do I multiply by 5 to get 30. And maybe you know, but let's say that you never know, right? What I need to do is to get rid of this multiply by 5 and carry it over the other side, right? When I carry it over the other side behind the 30, I'm going to change the sign from multiply to divide. Because it switched side, so the sign should also change. So I'm going to get x is equal to 30 over 5. Remember, this divide mean over 5. Fractions same way. Don't get it mixed up. So 5 into 5 goes 1 time, and 5 into 30 goes 6 times. So x is equal to 6. It's easy though. It look complicated, but it's easy. You see it? Now this is an interesting case. We have a raised to the 0 power and we're dividing that by a to the 4. Now you remember the rule? Once you're dividing and the bases are the same, you keep back the base and subtract the powers in the order that you see them. So a to the 0 divided by a to the 4 is going to be equal to 0 take away 4. I hope you never say 4, you know. Negative 4, right? Because you have nothing, but you owe the people them 4. So you end up still owe them 4. But look at it again. We said, or we saw and experimented and saw that anything raised to the 0 power is 1. So I can rewrite this as 1 divided by a to the 4th power. And that will be giving us a to the negative 4 same way. But then I can rewrite this part as a fraction because of this division right here. So look what happened. 1 over a to the 4. So both of these are supposed to be equal, right? What do you notice about the power and the base? Over this side, the index or the power is negative, but the base is basically a whole number, so to speak. Over this side, the base is written as a fraction and the index is positive. So we can say that to rewrite a fractional index or a fractional term with index in the denominator, you keep the base and rewrite the index to a negative 1. See that? To a negative index. So for example, now you might have 1 over b to the 3rd. What am I going to do to write it as a to change the index to a negative 1? I'm going to have b negative 3. See? We're following the pattern. What if the case switched? So for example, we had c to a negative 5. What do you think you're going to do? Well, you have 1 over c to the 5th. See there? So what some teachers use to explain the concept simpler is that they say, once you see a negative index, it means that you change the negative to a positive and the base crosses the line. So I'm crossing this base. I'm using this base to cross the line. See me draw a line there? Crossing, using the base to cross the line. I'm going to get a C, change the index from negative to positive and put it under 1. There you go. Now here we have some trick questions. It says to rewrite the following to have positive index only. A. So when you look, you have a to the 5th and b to the negative 2. Now I can rewrite this as a to the 5th. Remember now, with the negative index, the base crosses the line and the index becomes the opposite. It becomes positive. So as simple as that. So let me show you how we do this step by step. So a to the 5 times b to the negative 2. A to the 5 will stay in our numerator, but we can rewrite b to the negative 2 as 1 over b to the 2. And remember, we still have that a to the 5 to multiply by it. So 1 times a to the 5 will give us a to the 5. And we'll have that b to the 2 in the denominator. As simple as that. Let's look at another one. We have x to the 3rd divided by b to the negative 2. Seems tricky, don't it? But it's actually easy when you follow the principles. So I can rewrite the denominator to a positive index by doing the same thing. But this time, I'm going to put it over 1. So it's going to be b to the positive index this time over 1. So remember now that x to the third is already over 1. And I'm multiplying it now by b squared over 1. Anything over 1 is that anything. So I'm just going to put them together. X to the third b squared. As easy as that. Easy cheese.